For the fourth time, we saw a SpaceX Starship Superheavy stack blast off and attempt the goal of some degree of full reusability, or at least demonstrate that we were on the path to full reusability. And this time around, things went amazing. We saw the launch of Starship and Superheavy. We saw the Superheavy do its boost back burn and land softly, gently into the ocean. We saw Starship continue off to space, attempt its reentry, and amazingly, we got full communication for the entire return flight, except for a couple of drops as it was re-entering the Earth's atmosphere. We saw in horrifying detail as the incredible temperature and pressure was starting to dismantle one of its fins, and yet, against all odds, the spacecraft made it through the Earth's atmosphere and landed gently in the ocean as well. And so, as a tradition around here, I've brought back two of my favorite space friends, Marcus House and Scott Manley, to break this down, to talk about what we were looking for at each point along the launch, and then to sort of consider this in context of the other big space news that had happened around the same time, and finally to sort of think about what the future holds. When will we reach this fully reusable two-stage rocket system? So enjoy this roundtable conversation about Flight 4 with Marcus and Scott. Scott, Marcus, it's good to see you guys again.
Good to be back.
How you going?
Good. All right. So this was a hell of a thing. And there's like a bunch of stuff that I think for me, I was not expecting to see. And that was the incredible camera work in taking off and the actual like complete nonstop coverage as the thing was returning back from space. That blew me away.
Yeah.
But I'm getting ahead of myself here. All right. So once again, I want to start this with what was the plan for Starship Flight 4, Marcus? What were they trying to test out this time?
Yeah, it was sort of an interesting plan because they dropped a number of the steps that they'd had on Flight 3. So Flight 3 sort of had these extra steps while they were, coasting close to orbit. And, they sort of had, propellant transfer demos. They had Raptor relights and things like this. They had a door open and close demo, and they threw all that away for this mission. They really just wanted to focus on re-entry. They wanted to get that re-entry, and they wanted to make sure they had the attitude control working as they didn't have for Flight 3. So all these things they wanted to make sure that they did right this time. And did they blow it out of the park this time?
So we saw the launch, Scott, and I mean right away we got that drone shot from like just this incredible perspective. Like if some cinematographer had sat down and gone, what's the perfect way to view the launch of a rocket? This is the one.
Everyone's doing the drone shots. Like it's not just SpaceX, but this one was particularly spectacular because not only was it a massive rocket viewed from the right angle in this rising sun, but we also had weather conditions, which were so the humidity levels were such that the pressure waves coming off those engines were visible in the air. You could see like a rarefaction wave heading out to sea at the low pressure point behind the pressure wave. And in that, you could see condensation forming. So you saw this going through the clouds. You saw, again, concentric rings of waves heading out. That was stunning. It was amazing to see. And also there was another camera angle. I think the drone followed it up and it passed very close to the sun, and you could see refraction of the very hard like shock waves that get generated during the rocket crackle is literally a shock wave produced by this instability in the flow streams. There were so many sights very early on that were just unique to this, and the conditions were just right.
And what were you looking for?
Well, first thing I was looking for is how many engines did they have? And they were missing one. But, that's one of the advantages of having lots and lots of engines is you have lots of spare thrust. You have lots of spare capacity. And if your avionics and guidance can adapt, then that's an advantage. The disadvantage is when they explode and take out the ones next to them, which, we've seen that happen with, the N1.
Yeah, and we sort of saw that engine go out almost immediately. As soon as it had sort of lifted off the pad, it was sort of out already. So not sure what happened with that one, but yeah, they've always got the extra thrust available there through the rest of those engines, and which wouldn't have been a problem. Immediately, everybody was, or many people were online that a little bit more negative maybe were immediately saying, "Oh, this is now not going to make it." Oh, it's like, no, it's fine. They can lose those few percent, and they can probably even throttle up a little bit higher than the normal. Because I'm not sure if they would be firing up at 100% thrust at this point, given that they're not carrying a payload of any sort. So they may not need to. They might be running at 90. I don't know.
Do we know how many engines they could theoretically lose? Has anyone sort of figured that out?
I think we've heard that it's like 3, depending upon the times that they lose them. They won't launch with that many out. But once they're off the pad, then they start losing them different times.
Because remember as well, that's it. And they throttle down through periods of max Q and things like that. So as soon as they're sort of up around that area, they could lose probably a bunch and still be okay. Certainly interesting watching it come through that initial, the first top-down shot of the ripples going out through that cloud layer was unreal, wasn't it?
Yeah.
And then we got the sort of went through the maximum pressure. That all went fine. We got the detachment of Starship and Superheavy. And again, another great shot showing that the ring, the hot fire staging ring, ejected away and sort of tumbling away from the rocket. How did that all look to you guys?
Well, that wasn't another shot. That was the first time we've seen the hot stage ring intentionally detached, right? Because there's a lot of evidence that it accidentally fell off during the previous flight. And having all that extra mass on it makes it slightly harder to land. So they obviously made a point of ditching it for this flight. And it was great to see that popping off on schedule. Because if you think about it, they originally had Starship was intended to sit on top of the booster directly. So there's these latches in there so that they can release it. Well, the staging ring is just like got its own set of latches, so it latches onto that and then latches onto Starship. So it's very easy to release it. It was designed that way from the start.
It's kind of cool that way. It's just like this little Lego set, almost like they just sort of reintegrate a new ring on top that's got the same
like Kerbal Space Program
connections. Yeah, that's exactly right. It was just magic watching it come off because the thing is that we assume the main reason they wanted to do it, and they even clarified this in the stream, is that it's a heavy component. It's got to support the entire weight of the Starship on top. So it's built pretty robustly. Some of the earlier stats that we'd sort of seen on it from the FAA, whether these are still accurate or not, I'm not sure, but it was around 20,000 pounds. So, the thing's around 9 metric tons or something like that. So it's not a trivial amount of dry mass. So we kind of assume that the reason they wanted to get rid of that was because the actual original boosters have been around for quite a while now, so they probably weren't designed with quite the appropriate landing equipment. There's header tanks and things in there that are so big, and they may not be big enough to actually hold the amount of propellant that you need with an extra 9 tons sitting on top of the thing. So that and extra stability issues probably because, the center of mass probably is a bit different to what it was originally intended to be and all sorts of things like that. So, it's pretty cool that they were just able to add this thing on there and it just ejected off. But that is a temporary thing, and they clarified that in the stream as well. That's only intended for these, as an adaptation to try to put this hot staging thing in last minute, because they only really bought that in between Flight 1 and Flight 2. So, it's pretty crazy.
That's a James Webb Space Telescope type of mass. 10 tons, 9 tons, right? Like that's a lot of mass to either re-engineer into your booster rocket or have to eject on every launch. So,
but they have actually added some other mass increases to it. Like since this booster design was originally built, the previous flights have informed change that they needed to make, and they've added strengthening to like the upper tank. They've added more shielding around the engines. They've added a heavier fire suppression system, and these were all things that were eating into the fuel requirements which were needed to make a soft landing. And this hot staging ring, that's another 10 tons, and it's just 10 tons that they can get rid of, and it gives them back more margin. You see, they didn't rebuild any of their internal header tanks that are needed for the landing. So, so there's this like big oxygen tank down the bottom, or it's a small oxygen tank that was calibrated for the landing requirements. And they couldn't change the size of that.
Just the weight of the stringers would be interesting to know, because those stringers are
they tripled
pretty
the
hefty,
number,
I would
right?
assume. Yeah, it basically tripled. I think there was 25 or 24 or something, and they tripled it to like 75
72,
or 74 or something. Something like that, yeah.
And so I guess they're just discovering the tyranny of the rocket equation. It is rearing its ugly head that if you're going to attempt to build this thing that can handle both the launch and the retrieval, you're going to need more mass. That's going to decrease the amount of payload that you can send to space. And I think we are waiting to see what the final calculation turns out to be. Let's move forward. So we saw the detachment, we saw the boost back burn for Superheavy, and Scott, how did that all play out?
The boost back burn looked textbook this time. There was no engine failures right at the end. It performed its flip and burn. As I said, the staging ring came off, and then it just leisurely began falling back to the Earth, with gravity inexorably accelerating it, bringing its speed up above like Mach 4 straight down over the Gulf of Mexico. And then...
it's just magic.
And then, obviously second stage is still going, but it comes down, it starts hitting the atmosphere, and I did some looking at the numbers. It decelerated up to like 5G at one point, and once it got to, I can't remember, it was just hitting the cloud layer, and it lights those engines. It goes very quickly from just over Mach 1 down to 0 in seconds. And SpaceX, so we originally saw this from inside, and one of the things that happened was one of the engines failed spectacularly. Well, I mean, I think that when you've got an engine lighting and failing and it's going into a supersonic airstream, it's going to blow out debris, whether it explodes or whatever. But we visibly see debris coming up the side of the rocket and a ball of fire. But the guidance system is able to compensate. It must throttle those other engines higher. Again, peak deceleration is about 5G under the thrust. And it slows down, switches down to 3 engines now, and soft lands over the Gulf. And we have a external bit of footage that came from SpaceX just a couple of days later. I saw that this
morning.
Yeah. And
so they knew, like, with precision where this thing was going to land. They had a buoy in location to actually track the landing, and so we saw, a third person view of this rocket coming down in addition to the one that was on the booster itself. I guess we didn't see that until later.
That was a really cool shot too, because you could sort of see quite a big flame coming out the back. Probably that engine that disappeared. I would say maybe it's got something to do with that. But yeah, quite a long flame tail as it sort of came down. So yeah, it was awesome. And actually, rewinding just a little bit, there was a shot of the top of the booster that we hadn't seen before. You could actually see like the grid fins. The actuator for one of the grid fins moving and things like this. And in that same shot, actually, you can see the big hot staging ring way in the background just zipping up. So that was coming in well behind the booster. Which it's crazy to think that a 9-ton chunk of steel is going to move down slower than a big fat mostly empty booster, but it did. So yeah.
You have to figure out the dynamics on when that was released and how it ended up getting ahead of the booster when they were both falling. But I guess there's sort of some sort of residual thrust in the engines that makes a slow difference until the atmosphere gets a hold of it.
It would have been really nice to know how accurate that boost back was and sort of its stopping to 0, because the big risk, and I'm sure we're going to address this later on, is not destroying your launch tower. And the question is, was this nominal for next time it actually attempts to get caught? Is it going to tear apart the thing? And I didn't. I mean, I guess we're going to wait for some kind of analysis after the fact, but I don't know if that was like, yes, it stopped just above the ocean and fell over gently, but was that gently enough to be caught and
right,
not destroyed?
So the vertical guidance is clearly spot on, but we're not clear how accurate the horizontal guidance is. And we've seen it that, yes, it is within spitting distance of a buoy in the middle of the ocean, right? But it has to be within like a few feet, right? Within a meter to be on the launch mount. And that is, we don't know exactly how close that is or how much cross-range capability. There is another shot, by the way, from the SpaceX, the one that was published later from the WB-57, which shows it coming down at an angle in a glide and also creating this big, shock cone, right? This vapor cone around it, showing that it is indeed still supersonic. Possibly the biggest vapor cone in history, by the way.
Yeah. All right. So with that part out of the way, and that was great. I mean, I think that was exactly what we were hoping to see. Yeah, an engine getting destroyed on the way up, or engine turning off on the way up, an engine getting destroyed on the way down, and yet it still pulled that off. Now, Starship is on its way to orbit. So what happened next, Marcus?
Yeah, I mean, the rest of that whole process was pretty perfect as far as we could see. They shut the vacuum engines off a little earlier than the sea levels, and they just used the sea levels to do that final insertion. They've got gimbal control, so they sort of shut those off so that they can control the attitude of the vehicle as it sort of gets into orbit. But yeah, that was all perfect. And, it was sort of coasting along. They had a lot of venting out the back like they did in Flight 3. Which wasn't 100% sure in Flight 3 whether that was sort of normal or whether they had any leaking or anything going on. We thought it was normal, but, this was exactly the same again. So we don't see any reason for any concern around that. Like a few people were pointing out, it's like, oh, look, it's leaking already. It's like, I'm sure that's intentional. But the cool thing after that was in between that phase, we'd lost camera footage. All of a sudden, lost all camera views. And so, are we not going to see, like, it was still receiving data. We could see the altitude and the speed was all coming through perfectly. So they had the telemetry on it, but we wasn't sure if we were going to see anything. And, Elon had posted on X to say, we're working on it. It should be back up in 11 minutes or something, I think he said. And, sure enough, up it came. It's like, wow. And we were just coming into the descent at that point. So
I don't want to be conspiracy minded, but it seemed a little weird that the moment they were reaching orbit, they turned off the camera, and then they coasted for exactly the moment when they needed to return from orbit. Now, I've heard people say, well, maybe there was some kind of mystery payload. That sounds bonkers to me. Like, why would they risk the mission one additional step and try to handle some kind of payload?
Well, would that payload be happy being on a suborbital trajectory?
Right. So whatever it was, it would have crashed moments after the Starship itself had returned to Earth. Yeah.
That's right. It doesn't really make a great deal of sense. I mean, they could perhaps have just wanted to hide like a test Starlink deployment or something. But as far as we know, nothing like that was on board. So, I suspect they legitimately had issues with the camera feeds for whatever reason. But it was cool that it all came back up just for the action, which was just phenomenal.
And so, Scott, as it was coming back through the atmosphere, I mean, the thing that we really noticed last time was it was flopping around in space as it was attempting to prepare itself. I sort of imagine someone jumping off a cliff and then trying to sort of, wheel their arms around to get themselves into the right position. This was rock solid the entire time. And then even as it was entering the atmosphere, everything seemed right on track. So again, what were you watching for as it was starting to return to Earth?
Well, also, in the previous flight, they had lost roll control and they were just trying to figure out how to get it pointed the right direction. But during this flight, it got up to, so I think the official time they called for atmospheric entry was about 45 minutes into the flight. So it just come over, the last land we saw was Madagascar. It's over the Indian Ocean. It's coming in. And what I'm looking for is like a nice, stable attitude. And it gets harder to tell because it's descending over the night side of the planet, so we're losing ground references. But the fact that we can't see like the suns or the horizon spinning around pretty much shows that it's maintaining attitude. Now, the other thing that we're wanting to see is that as the atmosphere gets thicker, we want to see it start using those flaps to control its attitude. It can use reaction control thrusters while it's in space. Once the atmosphere gets thicker, this was going to be the first time that we wanted to see hypersonic, like flap controlling the re-entry. We'd seen this during the early Starship flights where it had flown up to 10,000 feet and then descend, or 30,000 feet and descended down. But that was subsonic. When you go from subsonic up to hypersonic, there's always the potential for things to go wrong. We weren't sure. It seemed that it worked on paper, but this is the first actual test and it looked rock solid. Now, the whole thing about Starship is that it has to do a gliding re-entry. And you may think, this is just a big blunt body, but they actually get aerodynamic lift from this vehicle. And if you watch during the descent, you'll see that the altitude comes down initially, and then around 6 to 8 kilometers, it basically flattens out and stays there for a long time as they're using atmospheric drag and aerodynamic forces to lift it up. So
that was brilliant, that part.
Yeah. So the whole entry process takes like 20 minutes. And that's because they're trying to control their descent and minimize the heating. You come up with a profile that makes sure that you're not generating too much aerodynamic load, too much heating all at once. And equally, it's supposed to be flying itself to its target site, right? It is presumably going to have some sort of roll control or yaw control so that it can perform cross-range corrections, but we didn't see any of that because it was dark. We didn't have any real attitude control.
I got through that max heating phase really quite early. I was expecting that to come a little, deeper into the atmosphere, but they sort of ticked that off really quickly, which I thought was quite interesting. And as you say, it was by the time it had sort of gotten down around that 60 kilometer mark, a little bit higher even, that the lift that it already had was pretty substantial for it to just sort of hang there at that altitude. It was just beautiful. And the fact that we were seeing it, we were seeing it with this uninterrupted signal way down into the atmosphere, which I didn't expect that at all. I thought that it would cut at some point, but it was just so stable almost all the way through. I think we lost signal a couple of times just briefly, but amazing.
We did lose a camera. There were 2 cameras that were viewing, and one of them disappeared at some point. I'm going to point out, though, that this is, people misunderstand atmospheric entry. The peak heating, right? The peak temperature of your plasma happens when you're going fastest. And it can happen when you actually have relatively low aerodynamic drag. So I'm not sure what they said for peak heating. That would presumably be, watts per square centimeter, but it might be something else. And they may not have had too much atmospheric drag at that point. And overall, you might have a higher thermal flux later on because you've got more atmosphere flowing past it at a lower temperature. And then there's a peak like max Q, which happens, about 3 minutes, 5 minutes before landing. It's a whole complicated process to go through all this.
Yeah, so I guess the point you're making, though, is when you hear, we've reached maximum temperature, don't breathe a sigh of relief. You're not exactly. We haven't reached maximum potential for destruction yet.
Yes.
And we saw that. So
right, and I think the best analog is that you can have an oven that's at 300 Celsius or whatever, and put your hand in the hot air, and you were like, wow, that's hot. But if you put that boiling water on your hand, which is colder, it will burn it, right? So it's the density of the gas is critically important to how fast the heat is transferring, and that changes as you descend through the atmosphere. And that's why you can make it through peak heating, and then perhaps only later on, do you start seeing some negative effects as hot gas starts to get places where it shouldn't.
All right, well, let's talk about those negative effects. So, Marcus, you were watching this. When did you start to realize something was going wrong?
I mean, it was probably about about 60 kilometers in altitude, where you're starting to really see these hot spots starting to burn through the forward flap, which was the only camera we had views of at that point. We'd I'm assuming we lost camera feed on the rear flap that we had to start with, because we never ever saw that again. But the camera feed sitting there looking at the forward right hand side we sort of saw this spectacular, burn through of the lower hinge, and
even before that, I mean, it was sparks. Like you could see that something was being ablated away that probably shouldn't have been ablated away. Like, and I don't know when you're like, this is what's expected. Okay, this is a problem. Yeah, when we get to the point that we could see the heat tiles burning off, the hinge burning through, then we're way into this is not what it should do. I mean, Scott, when did you think this is all fine? Oh no, wait, this is bad.
Well, so seeing small individual sparks wasn't unexpected. You've had a vehicle with a heat shield that's been sitting out in Texas. Like, it's had all sorts of random crap. There's insects that have gone up to that.
Bugs.
And bugs have gone and they've made their homes in the cracks between those tiles. It doesn't matter. So you're going to have all sorts of random dust and debris that will come off during reentry. That wasn't necessarily a thing, but at a certain point, I did start to see from the camera that looked towards the rear, I did see evidence that there was heat, hot gas flowing out of the hinge on the leeward side. And that was before we lost that camera. And then it switched to the forward-looking camera, and I could see what was definitely a persistent hotspot flowing around that wasn't near the hinge. It was a little distance out. I was wondering, have we lost a tile on that side? That's what I began to think. So if you look, there is like a persistent hotspot that's running up about 1/3 of the way out, or maybe it's 1/4 of the way out along the thing. So there may have been damage already at that point, and that may have been related to all sorts of other problems. I don't think they lost tiles on the flap during ascent. I think this is just dealing with hinges. Anything that moves means you've got gaps and you've got pressure differences. You're going to have gas flowing through those cracks, and that's eventually going to start hitting things and causing problems. And so then we saw the first bright spot at the root of the hinge, and then we audibly heard the crowd gasp as they saw this just burst through with a stream of plasma, and then slowly you could see the ribbing structure inside the fin as it basically heated up. The heat is being transferred through, and you get hot spots on the surface where the heat is coming through most quickly. And that, of course, then begins to melt, and it just bends back like a piece of plastic. Tiles are coming off.
Yeah,
and the tiles are sort of coming off from everywhere.
Yeah,
they're just sort of popping up from the opposite side.
But this is the advantage of that night reentry, is we got to see all this stuff. Like,
you could
if it was
see that
daytime
in
and it was coming in, we wouldn't have seen it. But because it was coming at night, we could see the warm glow coming off of parts that really ought not to be that hot. So what happened next, Marcus?
Yeah, I mean, we all, as soon as we started seeing that melt through, down around that 55 kilometer mark, as Scott just said, we thought that it was over at that point. It's like, this thing's going to lose that flap any second, and it's just going to start tumbling, and that's going to be the end of any chance of the landing burn, the flip or whatever. But and all of a sudden the camera gets obscured. There's debris all over it, and then the camera cracks, the lens cracks. Like, oh man, this thing is just totally gone. And further and further, it's still got signal. You see little sparks zipping around everywhere in the darkness. It's like, wow, this thing, I mean, it's amazing that it's still got signal. We kind of thought that it would be tumbling or almost be out by now, but down it came. We had telemetry all the way down. It's like, you could sort of start to see just little hints or little glimpses that the fin was actually still attached. It's like, what? It's still attached? And, right down to the landing burn, all of a sudden, boom, the engines fire up, and there's enough light made by that. Even beforehand, actually, there was something sort of lighting it up. I'm still not sure what was going on there, Scott. Like, we sort of had light going on even before that landing burn. Something must have been on fire somewhere.
Yeah,
I have no idea. There might have been a fire.
Lit on fire. Yeah. But I mean, even before we got that, it reigniting its engines, it had to perform a series of maneuvers to get itself to do that belly flop maneuver. And that's where that flap, under extreme strain, still was able to do its job. Scott, did you see any problems with the with that sort of final maneuver?
Well, there was one point where I saw it begin to go nose down. I thought, oh, that's it. It's lost its fins on the front. It can't generate enough drag. It's going to go nose first, and then it comes back up. And it's very clear that the guidance system was able to, it was an intelligent guidance system that was able to understand that they're not getting quite the performance they need. It needs to, retrim. And it got itself into a perfectly horizontal attitude. But also, if it was off target, it was entirely possible that it was going nose down and pointing at where it was supposed to be. So we just don't have a complete set of telemetry.
Oh, interesting. So it did, it almost like it did that on purpose to.
It could be intentional or it could be accidental.
Yeah,
right.
Because I agree with you 100%. I saw it dip down. I'm like, that's not helpful.
Yeah, that was totally consistent with it not having enough drag on the nose. And
and so it was trying to give itself. Speed up a little bit, give it some more drag on the nose but then it did it. It did belly flopped for a while, and then it, at the right moment, flipped around, fired its engines. Once again, we had
just amazing,
barely a camera remaining, but I, maybe it was my imagination, but I feel like I saw ocean. I feel like I saw splashes.
Yep.
Yeah, no, it was terrific. I mean, you sort of saw the flap. It's hanging on by like a thread. It sort of bends all sort of crazy, and it's sort of doing this maneuver like the other fins would be at the same time. Comes down, as far as we could see from the little diagram in the bottom, it came down almost perfectly vertical. Although you only get so much information from a 2D diagram, and sort of down it comes. None of the engine lights actually showed on the diagram to the right hand side either. So, but we know that SpaceX said that all three did fire up. So, down it came, landed, and it sort of does this graceful sort of flip over into the ocean, and you just, in the last glimpse, you sort of see the fin just come flying off, like it was just the most
in a strange way. It wasn't,
Bends in a way it wasn't designed to. It was helpful that the fire burned off a little bit of the soot. We got a little bit of a better camera view right at the very last second, so we could see a little more. But and then it was gone.
And as far as we know, that it was just a couple of kilometers off where it was intended to be.
6 kilometers off. That was the official number.
Yeah. So that's cool,
Yeah. And unfortunately, we don't have any footage. I mean, I'm assuming they flew a plane, or maybe
there
they had a
is
boat.
An aircraft that flew to the area. It's a Falcon 900 flew out of Australia and loitered in the touchdown area, but we don't know what it did. But it had to have been working with SpaceX to be in that area.
All right.
Yeah. Fingers crossed we'll see something at some point. You never know.
So now let's sort of give our official judgment here. Each of the times before this, we were like, was it a failure? Was it a success? Marcus, what do you think? Was this a failure or a success?
Look, it was overwhelmingly successful. Even before the flight, Musk had sort of had an interview, I believe, with Tim Dodd, and had sort of said, not 100% convinced that the flaps are going to hold up there. It was almost his number one concern of which part would sort of fail first. But look, I think it was incredibly successful to have that attitude control perfectly fixed up. We know that we had issues with clogging in the previous flight where it just didn't allow them to, use the roll thrusters or maybe some of the other attitude thrusters at all. So that was a great thing. And so it ticked off all those boxes. We had the booster land perfectly, with the exception of the one engine out. Success. Yes, it can be better. They're going to do all sorts of stuff with the heat shield next. And I think it's
Scott,
great.
do you concur?
I concur with all of this. I want to say mad props to the people that worked on the guidance software, because we had failures on takeoff, booster landing, and Starship landing, and the guidance software was able to accommodate all this and get it to the final to a correct soft landing. I'm going to say that this is a somewhat successful test of an older style of Starship. We're already looking forward to the next version, because obviously we have issues with hinges. Hinges are going to be just a really hard thing for them to solve, and they've already got changes in the pipeline, moving of the fins to make sure that, or to try to reduce this. it just shows the problems that they're going to have to solve going forward. So yes, a successful test of hardware, which is essentially redundant at this point.
Yeah. I mean, and so, last time we talked, my concern was the reentry, the heat shields, being able to make this reusable. I 100% agree that this version of it, this test was perfect, and considering, including the failures that happened along the way, it's amazing that it pulled off the whole thing together. And I think, in this state, even if it isn't fully reusable, I think we now clearly have access to a new heavy lift vehicle that could launch heavy telescopes, that could do a lot of really interesting work in space, even if both parts just continue to be destroyed afterwards, and they continue to try to figure out how to make this last. I mean, we could go years, I think, in continuing to iterate and still be able to get a lot of value out of this launch system. And so I think for me, it felt like we crossed a milestone at that moment.
Yeah. Look, I mean, even what we were saying last time is if they're able to reuse the booster, that's an incredible thing itself to have something that's heavy lift like that. They could presumably make expendable, and I think they do intend at some point to have an expendable version of Starship for super heavy loads that they want to get up there for any number of reasons. So just being able to do that is going to be incredible. And that's kind of a game changer before you even hit the reusability on the Starship, which is the huge hurdle. But I'm so impressed that they were able to. I mean, you wouldn't have had any failures with the main tanks, because things would have disintegrated really quite quickly. You would have lost pressure everywhere. So the fact that everything's come out to the point where they could still do a landing burn and everything, I think that's a spectacular milestone to have ticked off. And since then, they've come out and sort of said, okay, we're aiming for a tower catch in flight 5.
Well, that's what Elon says, but he has other engineers. Right, he may have other people that say, you know what, let's talk you down
Maybe
from
not.
this.
Right.
Yeah.
I would like to see them have
crazy.
the second tower built before they try to start catching things.
Yeah, but, I mean, I'm personally not convinced that they've demonstrated full reusability.
No.
I mean, I think that is I think a lot of people are like, well, that's it. That's, clearly this is all going to work. And I am very skeptical that they are close to being able to land the Super Heavy safely on the launch platform and pull Starship back from space and have it land. And I think it was an absolute success in what they were attempting to do and demonstrating the power of a new heavy lift launch vehicle. And yet I think we need more time for it to become a true, fully reusable two-stage rocket. And that's fine. Like, what's the rush?
I fully will not be surprised Artemis. If they go backwards at some point, right? If they find, because there's too many things that, sure, that fin being disintegrated to the extent it was and still working, that was miraculous. But hey, next time if they have that problem, they might lose more of the fin. It might affect the hinges more. It might jam. So I don't think they've solved this by any means. I think they've proven that it can be solved. And I think that they're going to have to do a lot more work on those air, control surfaces.
I think that's perfect,
and the work's interesting.
It's an engineering challenge. They've proven that it can be solved. Now it's a matter of solving it, but that could still take years. I mean, think about Falcon Heavy. Like this, just because it's probably going to work and then making it work, these are different steps. Go ahead, Marcus.
Yeah, I mean, they've just sort of come out. This is all in the last 24 hours or so. They've said, or Musk has said, that they're going to replace the entire heat shield on the next ship. So the next ship's actually already got a full heat shield. They're going to strip all that off, and they're going to put an entirely new heat shield on that's about twice as strong, they're saying. I'm not sure what is involved in being twice as strong, whether it's a lot thicker, whether it's just made out of more dense material, whether it's twice as heavy. We don't quite know what that means yet. The tiles
are they talking
sort of
about just
ceramic
the fins or the hinges? Yeah,
I think they're talking about the whole thing, because it's that's the sort of the wording that he used there. So
Yeah, I heard someone
it's sort of-
describe they were going to be attaching the tiles in a different way. They were going to be welding them onto the Starship, which is, I guess, pretty big commitment. If they do fail, then you're going to have to figure out a way to detach them to replace them. So,
yeah. So right now the main tiles on the Starship are attached by 3 locking pins, and it makes it actually easy for them to replace broken tiles. But if you start gluing them on, then guess what? You're back to a lot of the problems the space shuttle had, right?
Yeah. The glue caused a lot of delays with this more recent flight. They sort of stripped off all the ones that were glued and replaced those with we assume some sort of new adhesive that was better.
And there's designs of tiles which use posts that go into the tiles in a different way. The other thing they could do to make it stronger is maybe if they're not talking about structural strength, if they're talking about heat resistance, you don't need to make it that much thicker to make it twice as strong, because it's actually it goes sort of like an exponent, a curve, and it actually drops off. The temperature drops off much more rapidly as you get closer in, because of the way the radiation works, where it's temperature to the power 4. So cutting in half the last step, it doesn't actually need that much extra thickness. I think it's just vague as to what he was saying.
Yeah, I mean, I love your thoughts on this too, because they mentioned, or he mentioned, that they are going to put some sort of silicon ablative backup heat shield underneath the main tiles. And it's like, okay, that sounds like a big change. At the same time as saying another month until we fly. It's like,
so
optimistic.
So I haven't heard this. So I would say that if you could come up with an adhesive that would also act as an ablative material.
As an ablative.
Right? And that's totally possible. There's because the types of stuff that are used to make heat shield are these resins, which it's like a caulk gun. They would fill in the holes in the Apollo capsules. If you use the same kind of adhesive, it will also act as an ablative material. Now, is that the best adhesive? Maybe not, but is it the best adhesive to protect against heating? It might well be. So
I think the words that he used was silicon felt or something like that. So there's some sort of and just something that could sort of ablate away. Because I mean, just before the flight, he'd sort of said, "Look, we're not really." We don't really have the design as such where we can lose a tile in most places without it causing a pretty big problem. It's like, okay, well, given that we're still having the odd heat shield tile fall off, as we saw, especially on reentry, there needs to be a backup underneath, and so that's what they plan to do.
I mean, it feels like there are now 2 more great milestones. The first milestone being, I guess, ever reusable. In other words, can you bring Superheavy back to Earth? Can you bring Starship back to Earth? And then take a year to refurbish it to a point and try again. And we saw that same cycle happen with Falcon 9 before, where they were bringing these things back and then they were taking a long time to get them back and operational again. And then that next milestone being rapidly reusable, that you were able to actually take the thing and be able to launch it back within that 4-hour window that, we remember his original, it's 8 hours for a Starship and 2 hours for a boost or something ludicrous like that.
Yeah, I mean, I've always sort of assumed that they, by launching that frequently, sort of meant, there would probably be, 3 or 4 in a row ready to go. So the booster could probably go really quite quickly if they nail any of the issues with reuse on that. Because, I mean, you got to also think you need to load the Starship up with stuff. So, you would assume that Starship comes off, they take that off it goes for inspections and maybe getting prepared for the next flight, but the next one's already loaded up, ready to go up. That's always what I've assumed by rapidly, by a rapid launching cadence.
So, I mean, obviously, if the space shuttle was launched and they could recover the big orange fuel tank and rapidly refurbish those solid rocket boosters and rapidly refurbish, that was the dream.
Yeah.
But they never got there.
Well, they never got there because they never got the money to develop Shuttle 2, right? Because NASA, they were all, Rockwell and everyone, they were like, okay, so we figured out, we built Shuttle, we know what's wrong with it, here's the ideas for Shuttle 2, which will solve many of these problems. But of course, no politician was going to fund more money on that.
It's such a big benefit with SpaceX when you really think about it, because they're not limited by those budgetary issues that come from government funds and things like that. Whereas I guess SpaceX, as long as they've got the funding to do it, and we know that they're already profitable with projects like Starlink. So these are big things that, and I suspect Starlink is probably more lucrative than what we even know, because they've got Starship, they've got all these military contracts going on in behind the scenes. We've already seen a launch of that. It's like you start to be a big earner, and the military's also got some pretty big reasons to want success in this project. So we always sort of whinge about the the NASA funding and stuff, but the military funding is gigantic. So you never know what sort of funding's being invested in some of these projects.
And if the military came along with a sufficiently heavy lift payload that didn't require reuse, that SpaceX would be happy to accommodate them.
Right. Now, last time we talked, we addressed the elephant in the room, and I just checked, and that elephant is still there, and that's Artemis. The requirement for Artemis is to launch and reuse, or I guess launch. Maybe you don't reuse; it doesn't matter. But to refuel one of these starships in space, and refuel the human landing system and send it off to the moon. Things are progressing, but do you think that we are in any way moving towards the kinds of requirements that NASA is going to need to be able to set humans safely down on the surface of the moon by 2026, which is, 2 years from now?
Right. Yeah. I think the real question is, after this flight, do you feel that it's the time this is going to happen was less or more than the last time that we talked, right? Has this moved the needle to the left or the right on the schedule? Because I'm not seeing that they are moving fast enough. But then again, I would be very happy to be surprised. I think actually it's worth mentioning that just in the last few days that there was a big Starship project which had an original date of 2023 officially cancelled. Right?
Yes.
Dear Moon.
Poor Tim.
Yes.
Yeah. And when it was announced, of course, I don't think many of us, I think many of us saw 2023 and said, well, that'll be nice if you do it that fast, but I fully expect this will take a bit longer. And it's taking a bit longer, and the people behind it are getting bored. And so, the behind Dear Moon got bored.
Yeah, it is surprising. We've seen this mission in the works for 5-6 years, but we got the announcement just 18 months ago of who was going to be flying on the mission with him. And now suddenly they've all been told, sorry, you're not going to space. It's a pretty, you would expect a little more patience. And I suspect, there are other reasons why this was canceled at this point.
Yeah, I think that was the thing that surprised everybody the most, that it was announced that close to the announcement of when the crew, had come on board with that. And really, there's so many reasons that you've got to sort of think, look, anybody that was thinking 2023 was going to happen for that mission, kind of been seeing it in the right light. Yeah, it just doesn't make any sense to have done it, to have thought in that way. And the weird thing was, it's a little speculative, but we saw Musk unfollow Mizawa.
Okay,
yeah. Back at the end of, I think it was like end of March or something, and there was a couple of flags that was like, oh, that seems weird. I wonder if Dear Moon's going to be okay. And then several months later, it's not there. So who knows what's happened behind the scenes? There's lots of rumors. There's lots of speculation. There's speculation about funding. Maybe he's not worth as much as he used to, and he doesn't really want to spend that amount anymore.
And he scratched his space itch by flying to the space station.
He did it.
Yeah.
Now, there's a bunch of other news, and I just want to briefly touch on it, just because it's all kind of interconnected with Starship. The first thing is, Starliner was actually capable of sending humans to space, to the International Space Station, although there were not without its problems.
Hiccups.
So, yeah, Scott, what did you're watching that mission? What were you looking for?
Honestly, I was just looking for them to do this most basic thing that and it's not basic at all, because they've set themselves really strict standards. There were things that cause launch aborts, which would not have normally caused launch aborts because they were dealing with a much more valuable cargo, right? So, like the chattering helium valve, the hydrogen, the pressure release valve that caused the scrub a few weeks ago, that would not have normally caused a problem on a previous launch. But this one,
SpaceX would have launched. Yeah.
well, and then ULA would have launched previously. But I think also what I saw was that ULA haven't been exercising their ground hardware as nearly as much because they haven't been launching as much. And I think that's when you start to see problems. You'll notice that most of the problems they had with the launch were all related to ground hardware, not the rocket.
Yeah.
The rocket's new out of the factory. But
we got the helium leak. We got 3
multiple
thrusters
helium
fail.
leaks.
Yeah.
And we keep on getting more. And so now they've made it to the space station. They made this decision to dock. Mostly, I think, because it would be sheer embarrassment to not dock and have SpaceX launching this massive rocket at the same time. But now they're still assessing the effects of the helium leak. It'll probably be fine, right? As long as they can get out and then perform their deorbit. The actual control system for re-entry is pressurized in a different way because it's in the capsule. This is a service module that's having problems. But hey, worst comes to the worst. They can get rescued from the space station if the Starliner can't safely fly home. Because SpaceX does have Dragon capsules that are capable of this.
Right. Yeah.
Yeah.
That would be a little
certainly
ironic.
Exactly what we didn't want to see, because they had all those helium leaks beforehand, and they took it away and they addressed them and whatnot, and all we're hearing over this last week is helium problems. They've had to close this valve and this valve to stop the leak and things like. Oh man.
Yeah, previously there was like hypergolic fuel leaking though in the service module. Yeah. So like this is at least slightly more understandable. Yeah. Helium is a nasty, sneaky little molecule or atom that will get everywhere that you don't want it to. But the good news is it doesn't do anything bad.
Right.
Yeah,
makes your voice sound funny. And then, Marcus, the other big event that happened on the same day that Starliner was originally supposed to launch was the Chinese landed on the moon with Chang'e-6 and retrieved their samples and flew back to orbit, and now the capsule's on its way home.
Yeah. It's just amazing how smoothly all that's gone. These are complex missions. This vehicle's 4 parts, broken into these separate components. It's almost like pulling off an Apollo mission, autonomously with robotic vehicles. Obviously, it's crazy all the different maneuvers they've got to do. And yeah, we even got to see quite a few nice shots of the surface sample collection and the ascent. The ascent back up to meet up with the returner vehicle and all these sorts of things. Like, wow, it's you don't want to write off what they're doing. A lot of people were sort of say, I wish you didn't cover this stuff as much. People that don't want to cover Chinese stuff, but it's like you got to pay attention to what they're doing, because what they're doing is impressive. It's like regardless of what political spectrum you're on, you got to take notice, because if NASA budgets keep getting cut and cut and cut, and yes, the NASA budget seems to be the same as it was the previous year, but that still means you're going backwards because of inflation and things. So you want to make sure that the population understands, hey, if we sit back and just mosey along here, the Chinese are going to be up there and they're going to have a lunar base, and we're going to say, why did we let this happen? Why are we not back on the moon yet? So, this is really important stuff for people to know about, regardless of what they think.
I will say that, while you're saying it looked smooth and everything. We got to be clear that we are having much more communication in the US. So we had these during the launch of Starliner. We had the launch loops available. We got to hear a lot of stuff that we normally wouldn't hear. We certainly wouldn't hear in a Chinese launch. All this troubleshooting that they went through, the problems with the soot fans, like all that stuff we get to hear. But we only get to hear when something is successful, generally on China's side. So let's not say it may look smooth, but that is because it is very carefully edited. You could absolutely take Starliner's launch and make it look smooth, right? It's like, we had another dress rehearsal. We had another dress rehearsal on June 1st. And it's like, and then we had an actual proper launch. Yes.
Yeah.
Right.
We decided to pause the launch so we could celebrate how wonderful this launch is going to be.
Yes.
Yeah. Yeah, I can sort of imagine that for sure. Yeah, I wish there was more transparency coming out of China. There's more transparency than I think I would have expected in the past, like especially when it comes to scientific data, it comes to science releases and interaction between the scientists and other people from other nations. They show up and talk at conferences, but yeah, that level of transparency during the launches would, I think, only do them good. Because it would demonstrate
it would show that they have confidence, right?
Exactly.
Because you'll find that nations that are concerned about their perception in the world will be the ones that hide any failure. Right?
Man, you hit the nail right on the man. I'm going to steal this forever because you're exactly right. It is showing a tentativeness and lack of confidence in their own abilities because they're not willing to show this stuff live the way the Americans are, the way the Europeans are. It is, yeah, man, you nailed it. That's awesome.
Yeah, that was a good point.
Marcus, any final thoughts?
Yeah, look, I mean, we're looking forward to Flight 5 with Starship and, all the different changes that they're going to put in place with the heat shield and that sort of thing. Interestingly, just hours ago, I got a reply from Musk with one of my questions, which was, how well did the other three flaps hold up? We could very clearly see the forward flap. And he replied and said that the left flap got very hot but was less damaged, and the rear flap seemed okay, but based on their control authority, probably lost some tiles. The rear flap seemed okay, but based on their control authority, but probably also lost some tiles. So they could probably see just from data that it wasn't perfect, but they held on pretty good. So that's a pretty good sign that they had pretty good control. We were looking at the worst flap of the four, apparently. So yeah, that's cool.
Yeah, there is differences in the hinge design on those locations because the hinge on the front is on a curved surface, like it's a surface that curves in two directions. So they have to have this section, this fairing that sticks out and provides the straight hinge section, and that's why there would be differences between the front and the rear.
The only other thing I guess I'd say is that we're still quite intrigued about the total dry mass and how much payload capability it has when there doesn't seem to be a lot of fuel. And we're still also not sure if it's 100% filled when at liftoff, because there's still sort of a slight gap in the bands, the frost bands, where we didn't see that in Flight 1. So it's still a little intriguing as to whether they're sort of just backing off the load a little bit just because they don't want a heap of extra propellant in orbit. Would make sense, right? But I don't know whether they're sort of doing that or whether, there's literally just not a great deal of load that's capable with this current version of the ship. It's hard to say.
I do wonder what that final launch capability will end up being after they've done all of the strengthening, all of the reinforcement, reintegrating the hot staging ring back into the top of Superheavy, whatever additional heat tiles are required, what other safety improvements come together. That number of like total launch mass to LEO is going to come down, and the question is, where will it end up at? Or what will be the total mass that you can deploy on Mars? Or what's, how many times can you use the human landing? Like, these are all going to, as the safety is improved, the reliability and reusability, that'll bring down that mass.
Yeah, biggest challenge, being that you've got to refill a tanker up there in orbit, and how many flights would that take? It's the biggest question in everybody's mind, probably, now that they know that, hey, this thing can re-enter and it can return and land. We just need obviously a stronger heat shield and whatnot. But yeah, that the amount of refilling missions that needs to occur to perform an Artemis mission, these are still the most critical questions. And developing propellant transfer systems and managing the heat and boil off and all these things that still have to be addressed. So there's still a long way to go. But yeah, it was spectacular to see this step of it.
Scott, any final thoughts?
Final thoughts. Well, roll on number 5. Yeah, I mean, look, we're going to be watching the changes that happen because Yes, we've seen that the margins are not what they expected to be, and there are significant changes coming down the pipeline. This will affect like the size of everything. It'll affect the overall shape, and I'm actually still most interested in how they're going to address the issues with the gas incursion into the hinge sections, because that is something that they're going to have to deal with. You're going to have your heat shield all the way inside that, but then you've got structural things that move stuff around. And then how are you going to build a heat shield that handles re-entry from the moon? Because the temperatures are going to be so much higher, and maybe your heat shield tiles can no longer handle the peak heating. Are you going to go to some sort of active control system in regions? Are you going to change formulations on your surface material? You can use something, like silicon carbide. I don't know.
How much faster are you coming in for a lunar reentry as opposed to an orbital reentry?
40%.
40% faster.
Yeah.
Wow.
And so that, you're basically coming in with twice the energy, but it's the rate of energy loss, energy dissipation that matters. And you need to lose like 40% of your speed. You need to lose half your energy before you start flying back up into space, or you need to intentionally skip and come back.
Yeah.
Mm-hmm. Yeah, that's a different ballgame altogether, which is just why it's so bizarre to think that, the guys running the Dear Moon mission didn't sort of say, there's a lot of steps to come. So, probably silly to announce things 18 months ago when there was just so much that had to be proven.
I think, there was originally going to be like a TV show and things like this, and none of that never happened.
Yeah. And there's other tourist missions as well.
Dennis Tito.
That's it. Yeah. So
he was the first space tourist. He wants to do this again still.
All right.
At one point, he wants to go to Mars. So
yeah, that's right.
Let's just get to space first. All right. Well, guys, it was always a pleasure to talk to you. I really appreciate the update. Good luck with everything you're working on, and maybe we'll see you guys after Flight 5.
Flight 5.
I hope so. Cool. Thanks, guys.
All right. Thanks.
Fly safe.
Cheers.
I hope you enjoyed that conversation with Marcus House and Scott Manley. Now, if you haven't already, I'm sure you do, but you should be following both of their YouTube channels. I'll have links in the show notes. You can definitely follow them. They're amazing. Some of the best space analysts that I know of, and that's sort of why I like to bring them back. Now, I'm going to give you some of my thoughts, but first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrew M. Gross, David Gilton, Dennis Alberti, Dustin Cable, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Modzo, Paul Rohrbach, Stephen Krasaki, Stephen Fowler Munley, and Vlad Shiplin, who support us at the Master of the Universe level, and all of our other supporters on Patreon. Like many of you, I was really excited about how well this mission went. I mean, we saw this enormous skyscraper Superheavy booster send the rocket into space, and yet it was able to then turn around and make a soft landing in the ocean. We saw Starship return through space and mostly survive, and at least get within a couple of kilometers of where it was intending to land. And again, land gently in the ocean. But landing these gigantic rockets in the ocean is a really far step from having these things return back to their launch platforms and be rapidly reused. And it feels to me like we're in this middle stage where we're going to have to wait a while before that final dream of full rapid reusability comes around. And I think this technology should be judged on sort of two parts. The first part is, do we now have a new rocket system that can launch heavy payloads into space and deploy telescopes of larger masses more simply than we've had before? And I think the answer now is yes, absolutely. I mean, they haven't done it yet, but I think that capability exists. And I think we should hopefully see that come together fairly soon. It would be a real shame to not see some heavy payloads blasted into space and demonstrate that this is here. But really, the goal, the dream, the promise of Starship is that full reusability. And the Artemis mission is counting on this, that you're going to have this thing be able to fly to space, refuel in space, to fuel up the human landing system for it to go to the moon and be able to land the astronauts safely on the moon. And that is going to require multiple launches. It could be done with multiple separate Starships, but then what's the point of building a fully reusable rocket if you don't do that? We could see a long time before we get to that final reusability. I hope we don't. I hope it comes soon. Humanity will be made better with a fully reusable two-stage rocket system and not having to throw out rockets between each flight. But space flight is difficult, it's hard, and don't be surprised if it takes longer. And so manage your expectations. I will continue to manage mine. All right, we'll see you next time.